Okay, so this is the last section in chapter 16, and this is the acceleration formula. So we'll see that all the problems we solve in this particular, well, most of the problems we solve in this section will require you to use the velocity formula, which we wrote probably 2 classes back. Velocity of point B is velocity of A plus omega cross the vector from A to B. The acceleration formula is the second formula there. It turns out that if the geometry is in plane, that is, motion is in one plane, then you can simplify that formula. And all the questions in this chapter, in this course, are going to be in plane motion. So you do not have to worry about that formula, the AB formula. You got to look at the simplified expression for AB. It turns out that you can simplify the last expression as minus omega square times RB with respect to A, where this is a scalar, right? It's a magnitude. So you don't have to do the cross product twice. Okay, so what I'll do is I will first demonstrate how to use that acceleration formula, and then I'll do a problem involving mechanisms like we did in the past and show you how to use acceleration formula to find accelerations of points or angular acceleration alpha and so on. Okay, so here is a basic problem. So find the acceleration of point B, this point. Okay, you're given the angular speed 4 radians per second, and you're given the angular acceleration, which is 2 radians per second squared. So fix the coordinate frame, otherwise you cannot write down the acceleration as a vector. So I fixed I to be along the horizontal as shown and J on the vertical. We also told that there's no slipping, which means that this point here, let's call that point C, the velocity of C is 0. Okay, so let's solve for acceleration of B. So the formula is acceleration of B is acceleration of A plus alpha cross R B with respect to A minus omega square R B with respect to A. Okay, so alpha is given, omega is given. The vector from A to B, we can write that easily. AB is unknown and so is AA. So if we can find AA, we can find AB because everything else is given. Now AA for a non-slipping disk is always alpha times R.
Only non-slipping.
Yeah, so non-slipping disk or roller. And how do you get that? Well, if you want to really know how to get that, it's like this. So if you have a roller, and let's assume that this is, I just drew a line from the center point down. What will happen is when the roller rolls, this point is going to move, let's say here. This is the point A. Because it has rolled forward, the point A is now going to be at some different point. Let's say, let me put it up there. Let's say here. Okay, this is the new position of A. So this length here, the arc length, is, let's call that S equals, so what's the arc length if the angle spanned by this is theta? This is theta. So that arc length is R times theta. Okay, S is the distance moved by point A, but it's also the distance moved by the center from going from here to here because it's not rolling. So it's not slipping. So this also is S. So if S is the distance moved by the center, then the acceleration is going to be d square S dt square, which is the second derivative of r theta, so it's going to be r alpha. And that's how you get the acceleration of A. I should probably not confuse this with, let me put that center to be A, because that's what is written there, and then let me call this point as C C, just so that it is consistent with the figure there. So A. Okay, we'll never ask you to derive this, but and the book will. I don't think the book actually shows you how to derive this, but that's how you get it. The arc length here is S equals R theta, where theta is the angle swept when the disk rolls, but that is also going to be the distance moved by A, because no slipping. Okay, so that's just an aside. Okay, so we know, see. Okay, so let's just plug in the values. We know A now. So AB equals AA, which is alpha times R. Alpha is 2. The radius is 2 meters times I, plus alpha is 2, but 2 is in the clockwise direction. So I need to put minus 2K crossed with the vector from A to B. This vector. I'm going to run out of space. Let me move this down. Okay, the vector from A to B is going to have a length of 2 meters. And then its direction is, well, it is at 45 degrees, but it's pointing in the second quadrant. So if I take that vector from A to B and resolve it along the x-axis, the x component is going to be in the negative I direction. So minus cosine 45 degrees I, and then the j component is upward, so it's positive. Okay, and then minus omega square r b with respect to a. So that's going to be minus omega is 4, so 4 square, and the same vector 2 minus cosine 45 degrees I plus sine 45 degrees j. Okay, so everything is known. Just a matter of the hardest part is the cross product, but that's not hard either, right? K cross I will be j, and K cross j will be minus I. And so if you simplify this, I'm going to write the final answer. You should check the final answer. After doing this computation yourself, it's minus, sorry, 17.31 I minus 8.49 j. So these calculations tend to be very lengthy. That's how it is, just because the acceleration term has three things there. It's alpha times alpha crossed with r b with respect to a minus omega square r b with respect to a. Okay, so that just illustrates how to use that formula. Now let's look at a problem involving mechanisms. This is what you might, this problem will not, a problem like this will not show up in the exam because it's too easy. Something like this is more likely to be in the exam. Okay, so let's read it. A member AB, the vertical length has angular motions shown, so 5 radians per second square. That's the angular acceleration, which is clockwise, and then omega, which is the angular speed, is counterclockwise. So I'll call that omega AB, alpha AB. Determine the velocity and acceleration of the slider C. Okay, we want to find the acceleration of the slider and the velocity of the slider. So the key is, well, really, just like what we did for velocity analysis previously, we tried to go from things whose velocities are known to things whose velocities are unknown. So in this case, we know the velocity of A, 0. Acceleration of A is 0 because it's fixed. We go from there to point B using either the relative velocity and or acceleration formula. And once we find the velocity acceleration of B, we'll find the acceleration of C and velocity of C. Okay, so we'll proceed from A to B to C and link those two using the formulas we've done before. So let's solve for velocity of B and acceleration of B first and then go to C. So velocity of B is velocity of A plus omega AB crossed with RB with respect to A. So velocity of A is 0. Omega AB is 4 radians per second counterclockwise. When it's counterclockwise, it's positive 4k, so 4k crossed with the vector from A to B. So the vector from A to B, I'm going to assume that I is horizontal, J is vertical, so A to B is going to be 2 times J. So that comes out to be K cross J is, we need to go clockwise to go from K to J, so it's minus I. Then acceleration of B is acceleration of A plus alpha AB crossed with RB with respect to A minus omega square, that's AB, times RB with respect to A. Okay, again acceleration of A is 0, so acceleration of B is alpha AB. Now if you look at the figure, alpha AB is clockwise, and clockwise, the 5 is clockwise. 5 clockwise is negative, so minus 5k crossed with the vector from A to B, the same vector which we wrote down earlier, it's 2j, minus omega AB squared, so that's 4 squared, times the vector from A to B, so 2j. And so if we simplify this, we get minus 10 k cross j, just like what we found earlier, is negative I. So this is positive I minus 32j. Okay, now we found velocity and acceleration of v. Let's go to c. Let's start with velocity of c. I always recommend you first find velocity of c and then solve for acceleration of c, because you'll see that when you find the velocity of c, you'll be able to find omega bc, which is unknown, and omega bc will be required to get the value for ac. Okay, always do velocity analysis first. Velocity of c is velocity of b plus omega bc crossed with the vector from c to b. Okay, so let's see what do we know about these things. Omega bc is unknown. Velocity of c is unknown. Velocity of b is known. Can we find b to c? Yes, we can, right? So let's find that first. This is 0.5. This is 2. So what is the 90 degrees? That is 90. That's 90 degrees. So what's BC? It's going to be, well, 2 square plus 0.5 square, right? Well, so you could potentially do the long way of doing this as well. You first find this length, find this angle, and then you know this vector. You need to find this vector. So sorry, I think I did a mistake here. This is incorrect, right? It should be C slash B. Not the other way around.
Why?
But that's the formula. See, when you have A, the A should always be second. Similarly, you should have that. The formula is always like that. When you have a B here, that B should be here. That C is always. We see that happens in BB. So that's the vector from B to C. So I need to find that vector. So one way to do it is to find this angle. And then you know the length, you know the angle, and you can find cosine sine. But here's the shorter way to do it. You don't actually have to go through the process of finding this length. Just a waste of time. You just have to, you pretty much know this is 0.5. I component. You know that the j component is 2. So the vector is simply .5 I, but in the negative direction, because this vector is that way, in the x direction to the left, and it's downwards in the j direction. So that has to be the, you don't even have to do any math, right? Okay, so we can use that here. Do we know anything else in this formula? So we know omega bc is going to be in the k direction. We know the direction of omega bc. Do we know anything about bc? We do not know the magnitude for sure. So we know the direction of bc. How is bc going to move? It's always going to move in the slot. And the slot is at an angle of, well, it's the 3, 4, 5 triangle. You know the direction of motion of c. It's going to be in this direction, either downwards or it's going to be upwards. Yeah, we can just start assuming it to be whatever you like. If you want to assume it downwards, you can assume it downwards and then write the vector. I'm inclined to assume it to be upwards, and the reason is just because when I assume it to be this way, it has a positive x component, positive y component, and then if that assumption is wrong, it'll come out with the negative sign, just like when I assume omega bc is counterclockwise, and when the answer comes out negative, I say no, it's clockwise. So what I'll do is I'll write VC. I'll assume VC to be this way, because then I have a positive x and a positive y. But you don't have to do that. So VC is the magnitude times a unit vector in this direction, the direction of the arrow. So it's a 3, 4, 5 triangle. So what I need to do is, this is 5, this is 3 and 4. So if this is theta, then I basically have to write sine theta, right? Sine theta for the I, but sine theta is simply 3 divided by 5. So 3/5 I. And then cosine theta is 4 divided by 5j. You do not have to find theta explicitly.
Should I be 4?
I should have 5. 4 and 3. Yeah, that's right. 4 is the I because it's along the I-axis, and so this is actually cosine theta, and this term is sine theta. So equals VB, which is minus 8I, and then omega BC. Let's just assume that omega BC is counterclockwise. See where we go with that. So omega BC is omega BC the magnitude, that's why I didn't put an arrow, times k crossed with the vector I just found, B to C, so minus 0.5I minus 2j. Okay, let's simplify this. 0.8 VCI plus 0.6 VCJ equals minus 8I minus 0.5 omega BC. K cross I is J, and K cross J is minus I, so plus 2 omega BC. So if I look at that equation, it's going to be, there are two unknowns in the equation, VC and omega BC. However, there are two equations because there's an I component on both sides, there's a J component on both sides. So you equate the I component, equate the J component. You have two equations, two unknowns, solve for those unknowns. Two equations by comparing and J and solve. So solving gives me VC equals minus 2.5, and the minus comes only because I assumed velocity of C is upwards, but it's actually downwards, which makes sense because the link AB is going counterclockwise. The angular speed is 4, so counterclockwise, so C is going to go down. VC is minus 2.5 and omega BC is 3 radians per second. That is in the right direction, I assume, so it's counterclockwise. So that helps me solve for VC. Let's go to AC. So AC is AB minus omega BC square RB with respect to C plus alpha BC crossed with RB with respect to C. This is not right. This should be C with respect to B. Okay, again the same thing. we'll find we'll end up in a similar situation where we know what the direction of AC is. It's going to be along that slot. We do not know what alpha BC is, and so we'll have to write AC as AC 0.8I plus 0.6J equals AB, which we found earlier from 2, 10I minus 32J minus omega BC is something we already found. It's 3 squared for omega square BC, and then there is C with respect to B, that's minus 0.5I minus 2J, and then alpha BC is unknown, so it's going to assume that it is counterclockwise crossed with minus 0.5I minus 2J. Okay, a lot of equations, but the essence is one unknown, second unknown. That's going to lead to two equations, one which can be found by equating the I components on both sides, like that's the first one, looking at the J components and equating the two. So generate two equations by comparing I and J and solve for AC and alpha BC. So AC comes out to be minus 13 meters per second square, and alpha BC, which was not asked, but it also, you can also find that 12.4 radians per second square. The negative indicates in both cases that acceleration is negative of what I assumed, and acceleration is clockwise. Okay, any questions? Okay, so like instantaneous center of zero velocity, there is no instantaneous center of zero acceleration. There is no such concept. So do not use instantaneous center to solve any acceleration problems. We can only use instantaneous center to solve velocity. We can only solve for velocity using instantaneous center. Do not use for acceleration. And you'll see, as you've seen in this analysis, a precursor to acceleration is velocity. So you've got to master how to solve for velocity. Without that, you cannot solve for acceleration, because we had to find a piece of information, omega BC, which was later used in this equation. Okay. So what I can tell you is for sure you will see a question on this in the exams. Based on not acceleration per se, but these three things: velocity analysis, instantaneous center, and acceleration is a very important part of this course, and we normally put that question in the term exams and sometimes also in the final. Very likely it will come in the term exams and the finals. I can't tell you anything about the finals right now, but for the term exams, surely going to get a question on this. So the only way you can master this is solve a lot of problems. It's very easy to go wrong when there's so much math involved, right? So solve a lot of problems. And there are only so many types of problems in the book. There are lots of questions, but it really boils down to getting to it. You should try that at home. Okay, at the instant shown, NA of the rod has the velocity and acceleration shown. Determine the angular acceleration of the rod and acceleration of NB. So, acceleration of B, and we got to find the angular acceleration of So if we naively write acceleration of B as acceleration of A minus omega AB squared, or B with respect to A plus alpha AB crossed R B with respect to A. So if you write that, we notice that, let's see what are the unknowns in this equation. Okay, AB is an unknown. We know the direction though. We know that AB is going to slide to the right or left, depending on how A moves. We know the acceleration of A. It's given as 5 meters per second squared downwards. Omega AB is unknown. You're not given the angular velocity of AB. You can find the vector from A to B. That's easy. And then alpha AB is unknown. Okay, so we sort of know we can assume the direction to be counterclockwise for alpha AB. So the only unknown there is alpha AB and of course omega AB. So we have three unknowns. AB, omega AB, alpha AB. And so when we try to write this expand this equation and write the I and j component, we'll see that we cannot solve for all three unknowns because we end up with two equations. Okay, so you clearly cannot solve this equation itself. So the key is we got to find omega AB in that equation first, and then use that equation to solve for alpha AB and AB. That's the key. So what it means is you got to do the velocity analysis first, without which you cannot do the acceleration analysis. So let's write the velocity formula. Velocity of B is velocity of A plus omega AB crossed with B with respect to A. So let's draw a coordinate frame like so. I, J. Write the vector from A to B. The vector goes this way. So it's easy to see that if 5 is the length of the ladder, 4 or of the rod, 4 is the vertical height, then 3 meters is going to be the horizontal distance because it's a 5, 4, 3 triangle. If you want to find the vector from A to B, that vector, we can see that the x component, the x distance is 3. So I'll write 3, and it is in the positive y direction. Right, the vector A to B is in the positive I and it's in the negative j, so minus 4j. So you do not have to find the angle and to use the other way of finding theta. You can just use it from the distances given to you. Okay, so let's sub that in. Velocity of B is unknown, but we know the direction. Velocity of B is along I direction. Velocity of A is given as 6. But in the negative j direction, so minus 6j plus omega AB is unknown, but we could assume it's in the counterclockwise direction, crossed with 3i minus 4j. So VBI minus 6 equals minus 6j plus 3 omega AB. K cross I is j, 4 omega AB. K cross j is minus I, so plus I. K cross j is minus, but there's a minus, so it's plus 4 omega ABI. So compare both sides. We have VB equals 4 omega AB and 0 equals minus 6 plus 3 omega AB. From those two equations, we can see that omega AB equals to, we just need omega AB, right, to solve for AB. So omega AB is known. So AB, we know the direction, so it's going to be along I equals AA, that is given as 5 meters per second squared downward, so minus 5j, minus omega AB square, so 2 squares, so 4, A to B, so 3i minus 4j, plus alpha AB, which is unknown, so let's assume it to be in the counterclockwise direction, times 3i minus 4j. Okay, so we have 4 minutes. So why don't you try to solve for that equation, solve for AB and pull the answer.
You're talking about stuff, I don't trust it. Like I've done like no solving, I'm trying to get to
How much do you get for 26? Okay, before you leave poorly answers, I'm getting 16 for 28 minus 12. Okay, I have to check this because a lot of people are getting a different answer. I might have made a mistake earlier on.